In the initial phase of our design, we first decided to concentrate on constructing a high-level logical design for our system. We very quickly determined that our system could be represented by 4 very similar segments, each segment representing 1 digit of our kitchen timer. Each segment would contain a binary counter, a BCD to 7-segment decoder, as well as a 7-segment display. We also knew that the tens of seconds segment, or the tens of seconds digit, would have to be slightly modified. That counter would have to reset to 5 instead of 9, as there are 60 seconds in a minute and not 100. Once these segments were arranged, the other significant step was to figure out how these segments would be combined. We knew that we could use the clock to drive the counter of the 1-second segment, but we didn't know what signal we should use to drive the other counters. After some amount of work, we determined that we could combine all of the outputs from one of the counters through a NOR gate. We could then take the output of that NOR gate and combine it with the clock enable signal as well as the clock itself through a 3-input AND gate and use that signal to drive the next most significant counter. In that way, the next most significant counter will decrement when these 3 following conditions are met. When the clock is enabled, when the counter in question is at 0, and when the clock's active edge passes, just as we expect.